Hello, my phenomenal viewers, and welcome on to this episode. On today's episode, we will be answering this GCE Advanced Level 2025 question 2, Moment 2. The question is under circular motion, and the question reads: a particle of mass 3 kilograms is attached to the center of a smooth horizontal table by a light inextensible string of length 3 meters. If the particle moves in a horizontal circle on the table with constant speed of 3 with 3 meters per second, find A, the angular speed, B, the tension on the string. So like I said, the question is under circular motion. And when we talk of circular motion is when a particle moves in a circular path. Now, the question has given us the mass of the particle, which is 3 kilograms. So mass of this particle is 3 kilograms. Then it has given us the length of the string, which is what, 3 meters, and it has also given us the speed with which this particle moves on the table in a horizontal manner. So V is equals to 3 root 3 meters per second. Now, for you to be able to solve this question, you must know the relationship between linear speed and angular speed. Now, for anybody that is undergoing circular motion, there is a relationship that exists between its linear speed and its circular speed. And that relationship is given by from V is equals to R omega. V here is the linear speed of the particle. R here is the radius of the circular path that the body performs. And omega here is the angular speed that the question has asked us to determine. Now, when you read this question, the question says that this particle is attached to the center of a horizontal table and the particle moves in a horizontal manner. So it shows that when this particle moves in a horizontal manner on top of that table, then the length of the string becomes the radius of the circular path that the circle forms. So R here is equal to the length of that string, which is 3 meters. And from here, we can see that our angular speed will simply be the velocity divided by R, which is equals to V divided by L in this case, based on the explanation that I've given. So this implies that the angular speed is equal to 3 root 3 divided by L, which is 3. So this gives us root 3 rats per second. So this is the angular speed. Now, if the A part of the question has been understood, let us move to the B part of the question. For us to answer this B part of the question, we have to understand that whenever a body moves in a circular path, then there is usually a force that acts towards the center of that circular path or towards the center of the circle formed by the particle or object that moves in that circular path. It is that force that keeps the body moving within that circular path, and that force is called the centripetal force. And this force is calculated using this formula. Centripetal force is equal to mass times velocity squared divided by R. So in this case, it is the tension of that string that acts towards the center of that circle. So it shows that the tension on the string is equal to the centripetal force that is acting towards the center of that circle. So this implies that the tension would be equal to the mass, which is 3 times the velocity, which is what? 3 root 3 squared divided by R, which is 3. So this implies that this tension would be 3 cancels with 3 here, then 3 root 3 squared gives me 27, because 3 squared is 9, then root 3 times 3 gives me 3. Then 9 times 3 gives me 27. So I have 27 newtons. So this is how you tackle this question. You have to know the relationship that exists between the linear speed and the angular speed of any body or any particle that is undergoing circular motion. And you have to know that for any particle to remain in a circular path, then there must be a force that is acting at the center of that circle that keeps it to be in that circular path that it is undergoing, or that it is moving along, and that force is called the centripetal force. So if you liked this video, please help me and share so that it can get to many students as possible. And if this is your first time coming across any of my videos, please do not hesitate to either follow me or subscribe, so that whenever I upload videos like this one, you would be notified. Thank you for watching and stay blessed.